The purpose of this particular machine that we developed basically was to cater to the R&D or the development market. People who want to do R&D, this machine is most suitable for development or product development purposes. This is the whole idea. We have a factory in Pune and to a 2,500 square foot factory. And we basically come from the automotive background. AMS India actually specializes in making cars. We design factories to make cars. We are almost a 100% export-oriented company. So we started doing all the manufacturing lines outside India. For the last 30 years, we have been designing various factories across the globe, and of course in India too. Most of the BIW lines we were designing. And as you know, in the automotive industry, it's always up and downs are there. The market is not very stable. So it was this particular situation when the market was very bad that we all had to do something to survive, and we developed this product called the 3D printing machine. And this product became very well used across the globe and very well accepted for R&D purposes. I'd like to just show you the whole machine in detail in the coming slides. But basically, this slide is just to give you a snapshot of what we are doing or what this machine is. Machine is both additive and subtractive, and which means that you can not only add material and make parts, you can also subtract and remove material and make parts in the same machine. You can accommodate 5 tools together. That means you can have different extruders put on the same machine, and we'll be able to make composites on the same machine. It is used for building composites. That's the whole idea. And we have developed a variety of heads. 60 different heads are developed on the machine, because of which it becomes very flexible and versatile. And that is why it can be used more for development purposes. Because when a product developer wants to make a machine or wants to make a product, he cannot look for 10, 20 different machines to make a product. You have everything in one machine. So at one place, he can make a design, he can build a part, and then he will have everything for testing and proof of this concept can be done on the same machine. The machine has a print capacity of 450 degrees centigrade. That means the machine can take its temperature. Any material that can melt up to 450 degrees centigrade can be printed on this machine. The machine can accommodate variety of material in the form of filaments, pellets, powders, pastes, liquids, or gels. Everything can be done on the same machine. So that is the uniqueness. That is why it's very flexible, because of its multi-material capabilities. And in the coming slides, I'll show you how it is made possible to do all these multi-material capabilities. The machine comes with an aluminum hot bed, because most of the plastics, if you're going to work with, you need a hot bed for it to hold. And so it will give a cast aluminum bed, which is very rugged, and it's nearly about 25 millimeter thick cast aluminum bed. There's a filament heater in which all the filaments can be used for baking purposes also before it is printed. As we all know, filaments are hygroscopic. This is one advantage. Machine has an attachment for bending the plastic sheets. It is also used for rotating the parts. You can tilt and rotate. All these flexibilities make the machine more and more capable to do more intricate, more different shapes of parts can be created on the same machine. That's the advantage. It has an inspection attachment. It has a laser cutting attachment on the machine. It has got a pick and place. It's got a gripper attachment for holding and moving parts from place to place. It's also got a UV curing and photo initiation capabilities. So the plastics or materials which can cure with UV can be used over here. It's also got an MPG unit for jogging, Industry 4 compliant. Also got machine vision capabilities. Basically, this is a machine that I'm going to talk about a little bit. But generally, these are the 3 types of machines that we make. One is industrial research machine, purely for industrial research, which can accommodate all types of industrial materials. A laboratory research machine is a much smaller version of the industrial research machine. The industrial research machine is a gantry type, whereas the laboratory research is a knee type design. And it's a much smaller machine. The print sizes of up to 200 only. And then I have a biological research machine, which I'll also talk to you about, which is going to give you details on how this machine is used for biological research purposes. That means it is used very much in the current scenario. A lot of machines have been sold for bio research. And these are 3 types of machines that we have, which I'm going to give it to you in detail and talk to you about the 3D printing machine capabilities with this particular machine. We have sold our machines to most of the R&D institutions across India. Many customers are there who have purchased it within India, and these are some of the customers recently who we have supplied. We have also supplied machines to many customers outside India. In fact, we have got more than 650 machines outside India in more than 35 countries. And these are some of the universities and research institutions who have purchased our machines. This is just to give you a snapshot of the type of customer profile who has our machine. Fundamentally, we have now, this is just a snapshot of the machine that you're making. But the concept of waste to wealth is where I would like to start off now and show you what this whole concept of waste to wealth is and how we have been working with Sujeev and others to make sure that this is this knowledge and this experience and this technology um, is imparted and sort of shared with everybody and as many people as possible, which can be really very environmental friendly. It's going to help us make our environment much better. We know that there is a huge problem of plastics. We know plastics are something where it gets generated and it is not recycled properly. It can only create more and more problem. This is known. So we have tied up with a company called as an organization called Precious Plastics. Precious Plastic is an organization. It's a global organization. It is there from Netherlands who support any organization trying to do anything in the area of recycling or reuse or plastic conservation or reducing plastic usage. So we have tied up with them, and then we have built a series of machines which make it very powerful for doing for recycling and making sure that the plastics that we are on a day-to-day basis using can be conserved and created into different types of parts. What are the types of machines that we have made? You just see on the screen we have built machines of small scale and also little bigger scale. If people want to do a little bit like an industry, they can take the bigger ones, or smaller scale, house level, community level, or just an apartment level can be done using the precious plastics machines that is there on the screen now. We have an extruder basically which can extrude materials. We have first we have a shredder. So a shredder is something which is a very low cost. I will show you the details and the prices of all these parts or all these machines also in the future slides. But fundamentally, this is a machine which has got a motor connected to a shredding mechanism or a cutting mechanism. The details of all these machines, the technology of making this, the drawings, the sources, the kits we will provide if you want. We'll give all the information related to this so that anybody can take this thing and make it on their own, or they can buy the kits from us and they can assemble it on their own and use it on their own also for their purpose. This is all pre-configured and made for just conserving plastic basically. Like for example, a person who just wants to start a small thing like he has got he's in the community, he has some bakeries nearby or he has some shopping shops nearby or he's staying in an apartment. One machine like a shredder can be purchased where all the plastics people can just keep putting into this machine and you get plastic pellets or plastic powder in this. There are companies who buy the plastic powder directly and they pay you the money for it. So in case there is plastics getting wasted, plastics can be shredded and this plastic can be given back to them. And then if on a bigger scale, these are different higher level machines, which is more like a semi-industrial machines for different purposes. And what we can do basically is once these pellets are available, directly people can buy it, or we can also go to the next level of creating these particular parts for an apartment or for our own house or for a park or for our community or anywhere. Machines can be used for creating all these parts. How we are going to do it, I will show you in the next slides. You can create all these things. Basically, a little bit knowledge is required on all these materials, which of course we will be giving it to you. And fundamentally, all the plastics that we use for our household community comes under the following categories. I have mentioned over here, there are 6 different types of material that is used. In any bottle that we have, in anything that we buy, they are all more or less on the same categories. Their PET material is polyethylene, PET or HDPE, PVC, LDPE, PP or PS. This is the only material that 90% we will get. And all this material that we are having, you can see can be easily segregated by having to check if it can be floating on these materials. If it floats on this material, we know it floats. That means it's very easy to identify what material we're going to use in this particular mechanism. So people can actually shred it And the moment they shred it and they dip it in this particular liquid, whatever material is floating can be segregated. So it is very easy to segregate. While shredding, we don't have to segregate the plastic. Once we shred it, we can just put it into a bucket consisting of this liquid, and whatever floats in this can be segregated. You will be able to segregate the plastics. And then what we do is, this is and then this shredded plastic powder can be taken, and there are a lot of companies who will buy plastic powders which are segregated and given to them in different colors also. So what we have done is, we developed a shredder which we have costed it out to be about 1.5 lakh rupees, because the motor and a gearbox is a 3 kilowatt motor and a gearbox 3 kilowatt gearbox with a shredding unit. Complete will be available as a complete one machine will be given if required. And then it goes on. If you want to have industrial level, it is much bigger and much more thing. Second thing is, we also have a small hand operated injection molding machines. There are a variety of dies that we have created which can be used. We'll show it in the future slides what type of parts are made. So with this, people who wants to either make parts within themselves, all these machines are the single phase, can be put in a house, can be put in a community, and there they can be used to make parts. Similarly, we have a sheet press, a compression mold press. These are all simple small machines which can be used by any industrial or somebody who wants to start their own industry. They can create all these parts, and these are the machines which are there for waste to wealth creation. What are the types? What we actually do is, we have the molds, we have the technology, we have the press, we have the heating elements, everything configured to create the different parts that I'm showing it to you on the screen. All these things we will be giving full-fledged support to manufacture and to do it locally within any, for example, just in waste, you can make the tiles. And once these tiles are made, it can be put in front of houses, put in an apartment, put in anywhere it is required. We can make stools, and we can actually use the people can use these things within a local community. And all this is created from waste. Nothing is don't have to buy anything. Whatever is being thrown can be put in these machines, and it can all be utilized for making all the parts that I'm putting on the screen. We have seen, and how it is going to be very useful is also shown over here. See, these are some of the parts that are being made, and we will give you the complete die, the designs, everything to make all these parts along with the machine. The whole idea is something like this. We all have to work together. We all have to come up with some sort of a relationship building. We all have to come across with some sort of a thought process wherein we can impart this across a larger population in the country for having to use, reduce, and recycle plastics to do all these. This is the whole concept of waste to wealth. What we actually support is, along with Mr. Rajiv, we have a facility where if there is an entrepreneur, if there is a student who wants to start a business of his own, wants to start something on his own, we are able to give him through some sort of a financing mechanism also, where the machines are provided to them. They can actually use, they can start making some money out of the thing, either as a part-time or as a full-time, or also they can use things. So they can start small. Maybe just buy a first, they just go with the shredding unit, and then the plastic is being sold. Then they get some money out of it. They can convert it into higher level. The investments are a problem for such people. So this is the whole idea of waste to wealth. And this is how we try to make precious plastics and convert it into a real wealth. And this is what we want all of you to be a part of this, for this particular process. So this is the machines that we have. If we have to go in for an industrial level machinery, we have extruders, we have filament makers. So we can shred the plastic, you can make it into a filament. We have a chilling unit where you can convert these plastics into real filaments. We can spool it, and then we can also use a 3D printing machine for printing it into different shapes. It's a little high level of work that I'm going to talk about from now on. What this machine does is going to be shown to you in the coming slides. I will talk to you a little more detail about the 3D printing machine, which I'm going. Yeah, I'll be talking to you a little bit more on the 3D printing machine that in the coming slides. Till now, I was just talking about converting from waste plastics to filaments to making filament, but now I'll be talking more about converting this into how this machine is, what are the features of the machine to be able to make parts of your liking or whatever it is required. Basically, this machine is called Hydra. There are two sizes of the machine that we manufacture. One is called AS and AT. AS stands for standard, AT is for the taller machine. The bed size being 400 by 600 by 500 millimeters tall in the AS, in the AT, and 400 by 600 by 250 millimeters in the smaller machine. That is the size of the part that can be printed. So once you have a filament, you can put it into this machine and we can be used for printing purposes. The machine is very accurate. The machine is all ball screw driven. It's got linear guides. It's like a CNC machine. It has got all CNC axis for control, which will give, and a closed loop control, so that you are going to get all the accuracy and repeatability to make real industrial parts, which is useful for real industry. Machinery parts can be manufactured on this for development purposes. And the machine has got different heads. It has got six tool positions, 5 tool positions. You can put 5 different tools on the machine. And we have categorized the tools into 3 different categories: cold flow option, warm flow option, and hot flow options. In the cold flow option, all materials which can be extruded in cold condition is in cold flow option. A warm flow is all metal which can be extruded when it is heated. That is, it becomes liquid, then you extrude it and solidify. They are all coming under warm flow options. Then we have a hot flow option where the metal is in the form of filament, and these filaments are already there. Even for metals, these filaments are available today. So we can print metal parts also using the hot flow options. So we have, I will go through all these extruders coming under the cold flow, warm flow, and the hot flow in the coming slides. But this machine also has an attachment for having a diode laser of 5 watt or 6 watt diode laser is there. It can be used for engraving purposes, making name plates, cutting foam, cutting thin sheets of plastic. Diode lasers are used, and that is what is that's a low power option for engraving. We have a high power laser option which can be used for really shaping. Suppose you want to make the shape of a gear, you want to cut in a thing, or you want to take wood and you want to make a full fledged, you want to engrave on using laser. You can engrave it also. So we have a 80 watts CO2 laser attachment on the machine. It also has a spindle tool option wherein you can use subtractive machining. That means you have a part, you would have made additive manufacturing, you would have created an industrial part if you want, then you want to make a hole, you want to tap it, you want to drill it, you want to do boring, any operations, you want this spindle tool is there. You can put a tool into it, CNC program, just like you use the G codes in a CNC machine, it can be used for subtractive operations also. The machine has got up to 6 axes. That means normally the machine, standard machine comes with X, Y, Z option. Here we have additional axis of ABC also capable, like a rotary axis, like a lathe axis, or like a tilt and a rotary axis, all getting as additional attachment onto this machine. And then it also got a pick and place capability. It got a gripper which can be programmed for segregation. You have hundreds of bolts and nuts coming. You can just make the machine pick up each bolt, put it under a laser head or put it under an inspection fixture. It is okay to put it in a bin, otherwise throw it out. So you can also use it for segregation of waste. This is very useful. Then a variety of metal. You can have a conveyor like attachment where the parts keep coming, and this gripper can be used for segregating the parts also, depending on the type or the color or the shape or the size or any feature can be measured, and it can be used for segregation purposes. Got a closed loop, and it's got a microscope. The other machine which I want to show in the same category was the knee type design machine, which is basically a laboratory research machine. This is a smaller one. The first one I showed you was 600, 400, and 500 size. In fact, for one of the for IGTR Aurangabad, we are making a machine 1 meter long. It is 1 meter by 600 by 500 size machine we are making. So machine we can make to any size that is required. And this is a smaller machine. This is a standard machine, knee type design, 200 by 200. 200 is the bed size, which is again used for making all the different types of small parts. And as I mentioned, some of the materials which we use or which can be made on this using the different heads, different types of heads that I mentioned was cold flow, warm flow, and hot flow. As you can see in the hot flow extrude material, we have different types of plastics filaments that can be really printed. We have normal plastics, which are low temperature plastics like ABS and PLA. And then we have engineering plastics like PVA, Laybrick, Waywood, etc., PETG or PVA, PCL, which are industrial grade plastics which are there. And also we can print high temperature plastics such as PEEK, or PPSU or Ultem, which is nearly at 415 degrees centigrade, it will melt. All these types of materials or plastics can be printed, 3D printed on the machine with hot flow extruders. On the cold flow extruders, we have different tastes. We have different clays, or which are all cold in nature. These are all extruded in cold condition to get the shape, and then it is cured either in a furnace or by open air or by a baking unit. But it can get into shape, and then it can be heated and cooled. And porcelain, for example, or silicone or rubber, suguru, all this material can be printed using cold flow extruders. We also have warm flow extruders. For example, you want to print with wax. If you get wax, wax, when it is heated, when it is warmed up, it becomes liquid. Then you can extrude it and it becomes solid. And then you get a shape, just like you want to make investment castings. Similarly, wax can also be printed using warm flow extruders. There are three types of extruder categories that I have. Different types of parts that we are going to make on the printing machine. Once we have the filaments shown over here, including teak and ceramic and everything can be done. I would like to go in little more detail on the different types of heads. The hot flow, cold flow, and warm flow heads have got different categories and different options. I will show it to you a little more in detail over here. The hot flow heads come as three sizes. MK1 stands for one motor and 250 stands for the temperature, 250 degrees. MK2 is two motors and 250. MK1 is one motor and 450 degrees centigrade. That's why, as I mentioned, we have high temperature plastics like teak and Ultem, which melt at 400, 420 degrees centigrade, can be extruded using the MK1 type 450 head. Otherwise, we have MK1 250 for all the plastics, and MK2 is used for plastics which are soft in nature, where the filament is soft and it breaks. So we have MK2 extruder, and then Ninja Flex, etc., can be used for printing in MK2. This is the first type of filament type of extruder, where you have filaments and they are used for extruding. The second category comes wherein you have hot flow or cold flow. Here we have three different materials based on which the extruding heads are made. One is aluminium. These extruders are made out of aluminium. You can see it has got a cylinder and a piston arrangement, but the piston actually is moved through a screw which is connected to a CNC axis. This is mounted as a tool on the machine. So when it rotates out here, it is along with the XYZ motion of the head. When it is moving along with the XYZ program unit, along with that, the amount of material that is going to come out is also programmed. So what happens is you will get whatever metal is coming out along with the XYZ motion is metered and extruded out. So you get very even, says layer by layer printing facilities. In this one, we have the aluminum extruder. We have a UV cure attachment. So which means along with the metal coming out, if you have material inside that which is going to start photo initiation, photo cooling, photo curing with the UV, you can switch on this UV. You can go up to 395 nanometers or 420 nanometers. You can program it. So instantly it will cool. Especially materials such as resins, such as silicones, which are UV curable silicones, can be printed with this particular head. Then you also have a heater. So you can also have a heating attachment on this machine. So when the metal inside, it is also kept in warm condition when it is being extruded. And then you have a heater and a UV cure as an attachment. Different types of options on the aluminum extruders for soft materials. Similarly, we have the same type of facilities where you have a UV cure, where you have a heater, where you have additional fan, etc. as attachments, but the body is made out of stainless steel. This is for special materials, materials which are hard in nature. Aluminum means metal is soft, so it can use for softer materials. This is for harder materials. We have stainless steel extruders, and in this stainless steel, you can put ceramic powders. If you want to print with ceramics, it is good that you use stainless steel and material which are corrosive in nature. There also we use stainless steel extruders. It also has a UV cure. It also comes with a heater up to 250 degrees centigrade, and with a extruder. It is also there with the UV cure and a heater as a combination, along with a quiet storm fan, because ceramics, when you come out, immediately you have to blow it so that it solidifies and remove the air. So you have a storm fan also along with this. The third type of extruder in the same category is made out of plastic syringes. So these plastic syringes are the normal plastic syringes which are used in all the medical purposes. where we have 120, 60 cc or 30 cc cylinders or 10 cc cylinders. These cylinders are also again connected to a CNC axis, and it's got a motor which is going to squeeze out the metal from here in different layers. I mean, in different at different volumes depending on what is programmed. So when you want to print, for example, you want to print Vaseline, or you want to print with resins, you want to print araldite, you want to print with quick fix, any such material you want to print, you can take this one because one time use. You fill it up in a plastic syringe, you can use it and then throw the syringe itself. You don't need to reuse it again. Whereas your aluminum and the thing are not reusable like this, you can continue to, that's why you use materials easily cleanable. Here materials which are not cleanable, which is gluing in nature, which is also going to be very adhesive in nature, difficult for maintenance. So you use plastics, here you use and throw it. It comes with a lure tip attachment. So different types of lure tips are also available from 0.1 millimeter to 2.5 millimeter diameter lure tips are there, with which you can use it for variety of sizes and shapes of the part can be printed in this particular attachment. You also got a mixing head because you can have two different heads mixed and heated. So like for example, you have araldite, you have the hardener and then you have the resin. So you can put hardener in one, resin in one, and then you can mix it and print in the proportion that you want, so that you'll be able to get the right strength of the metal that's been extruded. Apart from just these three types of extruders, I'm going to show different options that are there, accessories that we have on the machine, which makes the machine very, very useful for manufacturing parts that we want. This is a machine where you have a diode laser. If you want to make nameplates, if you want to cut some edges, or if the part is printed, you just want to use it for curing, or you want to engrave on top of the machine, it's on top of the printed part, you can use a diode laser where you can program it, put it as one of the units or one of the heads on the machine itself. So after 3D printing a part, on the part itself, we can engrave the name or the face or the shape or photograph of the person also can be engraved using this diode laser. We also have for people who want to do research, who want to use this machine for more doing some sort of a research and paper publishing. We have a microscope where you can program using a G code, layer by layer. You can take images and store it while printing. So people who have put 1000x microscope, so people who want to publish papers would like to use this facility for taking images, creating their own reports and publishing papers. We have a facility on our website. I will show it to you later how this particular paper publishing is provided and encouraged for R&D purposes. For research-oriented students, it's very, very useful. Our machine comes also with an attachment like a box furnace. So for all the ceramics, wherever you want to use it for curing or metals or metal with plastics which is being extruded on this machine, you can put it into the furnace and then you can make metal parts. And that is why we have a box furnace, and then a magnetic build plate also is there along with the machine. The machine comes with a powder feeding attachment. So if you have powders like sand and iron powder, you want to print it, put it in layer by layer in a crucible and use it for melting or making metal parts, you can use the powder feeder attachments. We have labels and sticker printing attachment also on the machine. The best use of this is done more by electronic students because they are able to print with conductive ink on the same, using the same attachment. So if they want to print conductive inks, they are using. So they can print on wafer thin. They can make their own type of laser. I mean sensors, etc. They are using the labels and sticker printing attachment. We also have a rotary attachment for printing peak pipes. Peak pipe, as you are aware, is something which is very, very hard, which is a very complex material which is used for printing peak pipes. And this is an attachment for peak pipe printing. There's a filament binding machine on which it can also bind filaments. There's a continuous bulk extruding attachment on the machine, which means that whenever there is material which is being extruded continuously, suppose you want to make bigger ceramic parts, there is an extruder in which you put the ceramic and then you continuously can keep printing bigger sizes, and you'll be able to make parts which are of different with the continuous thing. We also have an IoT inspection attachment on the machine over here, which can measure the components which are being done, store it in a remote server. So in case you want to have it for, because an IoT attachment, whatever is measured can directly be seen by the OEM or your boss or whoever wants to inspect part can also get the readings immediately. There are more attachments on this machine. We have a gripper attachment for segregation, the filament baking attachment, the bending attachment. It's got a heater also behind. So a sheet of plastic can be put, can be heated and bent as a bending attachment. This is the spindle tool and a rotary attachment, the turning and milling attachments. You can also do turning milling operations on this. The hot air blower attachment. So basically, all the material can be heated once it is also printed. So your surface finish can become excellent after you can blow it with hot air after 3D printing. This is a 40-watt CO2 laser attachment wherein you have a laser behind and that is being sent onto a laser head, which is used for cutting operations or for real CO welding operations. Laser cutting operations. And then one of the things what you have done for educationists, for students, or for colleges and people who are in training department, we have made a pen attachment to the machine. So people who want to learn G codes and M codes, first we put the pen. The teachers will teach all the students what is G01, X so much and Y so much. So the pen will draw it on a piece of paper. So we stick a paper on the bed and then put the pen. So most of the students can be trained how to do the CNC programming because of the pen attachment. And this is a very unique feature which is being liked by many of the colleges who have purchased our machine. They are using this for teaching the students. See that you don't crash the machine. The pen never breaks because spring loaded. So the students can be made to learn G codes and M codes very well as a part of training. So this is a pen attachment. Apart from this, we have very good connectivity on the machine. We have put a OPC server on the machine. The OPC server makes all the variables get remotely accessed by a server. So many of the computer science students who want to do machine learning or who want to do some artificial intelligence research purposes are using the OPC server capabilities of the machine to get the print data out of the machine data out of the machine on a server for doing their own collecting the data and for doing their own research. There is a machine vision camera on the machine. So basically, whatever is being printed, most of the time it takes a long time for somebody for a print to happen. You can also see it on your mobile. Wherever you are, you can see how it is being printed, which layer, where it is being printed can be easily done using the machine vision attachment, which is there on the machine. It's also IoT enabled. It's Industry 4 compliant. You can actually go to our website and you can see all the videos related to this, related to our we have team viewer session also on the machine. If there's any problem that the machine is there, we're able to remotely log in and help you solve or remotely solve the problems on the machine or do the maintenance remotely. And so we have a team viewer also attached to the machine. This is all about the industrial research machines, that is System 30 and the Hydra machine, which I have been talking to you, which I have presented till now. From now on, I will talk to you a little bit more on the biological research machine that we have developed as a part of 3D printing. The biological research machine has got a very small print size, only 100 millimeter MX size. It has got again a very accurate machine. It is a completely direct drive driven mechanism out here, and this is used mostly by for the bioelectronics or mostly used for medical applications. This is if people are going to use this bio printers, and if they want, they also buy this biosafety chamber, which is an add-on to this machine, which they can keep the whole thing inside. They're doing something with biohazardous material, then the biosafety cabinet is required. But without the biohazardous material, they can use it on normal circumstances also. So this is a biosafety cabinet which we supply along with this machine. Basically, bioprinting happens by extrusion. So the same syringe that I just showed you some time back, the SDS syringe, the same syringe is used, but with a little different configuration for bioprinting. The print in what is called as a well is like a small petri dish. You can see over here, into which the bio tissue engineering or tissues or cells can be extruded out from an injection syringe and put in layers, and then we can mix and match. What is being done in bio research today is they build what are called scaffolds. Bio inks are very fertile for multiplication. If you put a virus or a bacteria in a bio ink, it multiplies very fast. So what is being done today is these scaffolds are printed using bio inks for different types of virus or bacteria. And this scaffold is nothing, it is simple, just like how we build a house and have a scaffolding around the house. On the same way, we build a scaffold in X, Y, and Z in layer by layer, basically in different shapes, just like a matrix. And this matrix are very fertile. It is very fertile for multiplication, and it is very good because it's got more area of contact. It's able to multiply very fast. And this is where they also use it for tissue engineering purposes. One can go through our website called Papers Published under Hydra 3D, HYRL3D.net. HYRL stands for High Reliability. HYRL3D.net, and you can see different papers that are being published by different schools from across the world. In fact, from India also, some of the people are now going to publish, and their papers also we put it up on the website. But I would request you all to please go through this website and published papers to see the amount of research that is being done on the machines that we are supplying. I just want to bring your notice to some of the biomaterials and their applications. Today, our machines, bioprinting machines, are used for a variety of applications, especially if they want to do some ceramics for dental purposes, orthopedic implants, or they want to do something for hearing aids with the things or dental fillings. Variety of applications are there on the machine, and the details of which is put in our website. These are all the applications for with which the bioprinter is used, and some of the materials which are available for bioprinting. On the engine HR, you can make scaffolds. They are making different types of scaffolds for human dermal fibers and cell survey. And these are all the different types of in vitro or vitro models. And these are the materials that are available for testing and for doing this type of research on the bioprinting. And so this is an addition to some of this is an add-on to the previous thing that I'm showing you more and more of different materials that is being printed on the machine. All the details of bioprinting liquids, bioprinting inks, type of research is there on our website. Somebody is interested, please go through it. And if you have doubt, you can call me separately and I will be able to give you more information. Different ink materials like gelatins, graphenes, collagens can also be printed. These are the advantages and disadvantages that I listed out here. Basically, what is being done on the machine? The machine is a very accurate machine, like I told you. We use the same syringe extruder that I had shown you before, the same type of syringe extruder. We use only 10 cc syringe out here. The biggest advantage is that in our software, we have given a very good software feature for printing. Like if you want to print a scaffold, I just need to say what is the size of the extruder, size of the well, and then I can say how many scaffolds I want in X, Y, and Z. Accordingly, the scaffold is drawn. The scaffold you can see it is a line by line drawn. Maybe we just say 10 micron difference in 10 micron difference to draw all these things. The same thing is being printed out with the biogel. So this is a graphical preview of the scaffold and this is the actual printed scaffold. You can see this scaffold, it is porous. It is like a sponge. It's printed like a sponge at the end of the day. So if you put in any liquid, immediately it absorbs inside and it is thing. Just to give an example, if at all this print in a bio ink and keep it open, if somebody sneezes next day morning, you'll find like a cauliflower. Now everything starts oozing out. So it is so much fertile this particular liquid is. And then you can see these are all the features on the machine, creating an auto wrap, auto dam, auto scaffold. These are all the most important printing capabilities of the machine to be able to do bioprinting. And that is what this machine makes it very useful for bioprinting. On the Repetrel, our software is called Repetrel, which is scaffold printing. It has got wrap, dam, scaffold, pockets, everything. All those features can be printed in a biowell, and they can do copies of multiple. Suppose you want to keep on, you have made one scaffold and you want to keep copying it again and again. Suppose you have 10 samples. Now you want to make 10 samples. So you need, suppose you have a 10 well chamber like this. You have only 6 out here. You can see. You may have 10. So I make program for one and start multiplying it and make copies for all the 10. So it's very easy with just G offsets. And not only that, the machine has a feature wherein you'll be able to do sub-zero or sub-ambient temperature printing. You can take the bed temperature below 0 degrees centigrade because many of the biological applications call for sub-zero printing. That means you have to take the temperature of the extruder to less than 0 degrees. So we have made a Peltier attachment which is going to cool it down and bring it to 0 degrees or less than 0 degrees also, which is programmable. And this is the attachment that I'm showing what we're doing. It's also got ultraviolet, very powerful UVC capable ultraviolet attachment. So after printing, layer by layer, if you want to kill the virus or something, you can actually expose it to this particular ultraviolet and kill everything immediately before discarding. So this is the attachment which got UVC capabilities also. Minus 10 degrees to 35 degrees is the temperature limit of this RST extruder. There is a mixing attachment on the head, dynamic mixing. You can have two different materials mixed and printed. The clench valve is actually pinch valve opening and closing. They're all making it very compatible for printing purposes. And this is the belt here. This is the bed getting cooled. You can see chilled bed, and you can also heat the bed. You can also cool it and heat it. You can see all ice being formed on the bed over here. Printing with different materials. Again, different types of body parts that can be printed for variety bandage purposes, for ophthalmology, for hot and cold treatments. Different applications are there. Fundamentally, what we have made now is a machine which is very much capable for a variety of applications. We have a very good relationship for reusing and recycling plastics. So we also have a very good relationship with Suprajit, and we are tied up with Siemens. Basically, we are training partners, we are channel partners for Siemens, and we have got Siemens giving us their software called NX, it's called DFAM, Design for Additive Manufacturing. So we train the students in design for additive manufacturing using the Siemens NX software, and a certificate will be provided by them. Along with Suprajit, we give training on the whole machine and on the whole technology of 3D printing. You can see different topics, different days. We have different training sessions that we have planned out for 1 week training program, 1 month training program, or 3 months training program, including on how to build machines, how to do 3D printing, all topics which are very useful for either plastics processing or metals processing, or for students to become entrepreneurs, including finance, including HR training. Everything is provided by Suprajit in totality, and to support anybody who is interested to start from scratch and convert waste to wealth. Our machines are basically certified. We are CE certified. We have a patent, and we also are an ISO 9000 company. So basically, this is what I have compiled and thought I'll just share with you all the features and facilities of the machine and the whole technology of waste to wealth, and then take your suggestions and take the relationship forward to help the public at large. Thank you all, sir. Thank you very much for giving me this opportunity. Sir, anything else, please?
Yes, sir. There's a question, sir. Sir, on the waste, on the plastic conversion, can you show the slide which you had shown the parts which we can make the plastic within the initial slides? And there's questions are coming on how to make this. Yeah. From this onwards, next products. Yeah. How to make these products and how can we go about this and the next one?
See, some of these are injection molded parts, simple parts. They're all hand injection molded. We don't need to go for machine injection molding. Like I showed you over here, this is a machine with which all these are made. It is a simple heater, but with a manual extruder where you press it in the hand and the material comes out. And then we have dies for all these simple things. For example, this bench and the bench beams that you are making, these are all made out of the press, sheet press. For example, you can see over here this type of a machine. Sheet press machine is there. It's a smaller one and bigger one. Both we have. And here these parts are being made. For example, you can make a simple sheet press, and they can make on their own. We'll give them the designs and we'll give them the drawings, and they can make it also. They can make the tiles like this, and they will be able to make it very useful. So giving the complete technology to the entrepreneurs or students or households or whomever, and thereby they can reuse and recycle plastic is the main objective. See, again, we have molds, we have designs for this. They can actually make these parts by hand. Actually, it looks good once these are all done. It looks simple, no? It's just a simple part. You hang it. You can hang a broom.
These parts are made by the machine.
Yes, it is made by the machine.
The machines which you showed previously.
Yeah, it is made by this machine. Injection molded parts made by this. First, you shred the plastic here. See this. You can see the colors out here. The colors, no, all this black and white. All this, you can see there are different colors. What is happening is you have a bottle coming out of Harpic, and then you have a bottle coming out of PETG. You have water bottles, etc. You mix all the plastic powder together, put it in a sheet press. You get this the mixed colors. Here you get colors. So there are ways by which you can segregate plastic, which I had also mentioned. Most of the plastics come in the form of PET, HDPE, PV. This is what is used in household material. And these are different ways by which you can segregate it. So first you shred it. Whatever you get, you put it in the shredder and shred it up. So everything is in the form of a powder now. This one, you just get a bucket of water and put it. Some of the things which will float in water, you can see this floats in water. So whatever floats, is HDPE plastic, take it out. So you segregate the plastics also. Then you can mix it in the color wise, you can mix it in different ways, and then you can actually put it in sheet press for making parts. You put it in injection molding press like this to make, we'll give you the dies, or you can make the die on your own. You can use it to make different parts, and this is all made in the house. You can make it in your houses. You don't need anything else. We'll give you the circuits, we'll give you everything to do.
Okay, I'll leave the participants can ask questions, please. Any questions from participants? Participants can directly ask questions.
Hello. Good morning,
Yes.
sir. Good morning, Shashi, sir.
Morning, sir. Morning. Tell me.
Hello. Morning,
Yeah,
sir.
please, sir.
How are you, sir?
Fine, then.
This you told us this all plastics material made in home. We can made in home. So first we have to this raw material. We have to shredder.
Yeah.
I mean all plastics we put in shredder.
Yes.
Mix like उसको बारीक करना है उसको मतलब
हाँ.
वो shredder जो है वो
वो श्रेड करने के बाद उसको पाउडर उसको मिक्स करके उसको हीट करके आप जो पार्ट चाहिए वो बन सकता है, आप ही कर सकता है. आई एम नॉट गुड इन हिंदी.
तो shredder how much cost of shredder? Can you show the shredder
Here
machine?
it is on the screen. It is on the screen, sir. 1,50,000 rupees.
1,50,000 ना?
Yes, sir.
अच्छा this one.
Stainless steel.
Shredder price अच्छा for homemade है?
Home. You can use it. You can use anywhere.
So this machine is available in the market everywhere, or I can purchase it from you only?
Like a kit, you can make it on your own, or we'll give you the design, or we'll manufacture and give you the kit. You can directly use it first.
Homemade plastic material, raw material, we can use, eh?
Exactly. All the plastics and the waste, plastic bottles, and
plastic bits.
Yeah, plastic. You get so like milk bottle maybe there, or curd bottle, or your Harpic bottles are there. So many come in bottles, na?
Whatever broken plastic,
And if you have a community like like a bakery, in fact, near our house there are some people like a bakery. We are told that bakery fellow has purchased on whoever drinks water, he'll put it in that, and now he is getting at least about per day is making 400, 500 rupees just out of waste plastic. He's getting that money. He's selling the bottle paper like that, shredded plastic, and people are buying it and taking it. See, if you are selling like a bottle, a scrap bottle, nobody will, it is of no use. So people will take it and they will just throw it somewhere and it is piled up and put in junkyards. If you are shredding it and immediately you are going to have it like powder, you can create parts and use it. So instead of people telling segregate the waste and at source, what you are doing is you are converting at source. Wherever you're getting this plastic, if you're in apartment, there are 10 houses in an
This is
apartment,
breaking. Hello.
bottles that will come. If one machine is there for that apartment, every month they will get 300 rupees, 400 rupees every day. The plastic itself can be consumed. You can sell it and you can make parts, you can make chairs, you can make whatever people want on their own.
For this different parts, we need dye. Is
Yeah,
that?
they are standard. We are not, it is very easy. We get the standard die. These dies are not like a thing. It is manually clamped and injection molded. This one. For this, all the dies are just kept on the floor here. It's a very simple thing for making.
Achha. Injection molded.
Yeah. Here you put all the powder inside in the hopper. You put the powder. The heater will heat it, and on the top you are just going to press it down into the die, and then you'll get the shape, and you can just open the die and take the part out. See, this is not like industrial level where it is not mass produced like industrial, but it is only to convert from waste to wealth, as I'm telling, which is used for your own household material, community wise. How many, this hand injection molding, how many parts can you make? Maybe, you can make one every 1 minute, but more than sufficient. How much do we need for converting our waste into wealth? Let us make one in a minute. Whereas in the factory, we are making one in every 5 seconds. That is the speed at which we are injection molding. Here it will take a minute. So what? But you can still make the part. Still heating and putting it into a die. It's the same technology.
Yes, little bit slow production, but it is protecting the parts.
Yeah. In fact, the dies also you can print on the 3D printing machine.
So these machines, you are developing this machine. You are making this machine.
Yeah.
This.
All these machines we will give if you want. And Mr. Rajiv will support. If somebody wants to start an industry or entrepreneurship, even financing schemes are available for them. So a person who doesn't, in a community, they can use it. They can take the financing schemes and they can repay the money. They can also use it for their own. It's not very expensive. 1 lakh may not so much, no. First they buy only a shredder. They start shredding, and then they get some money out of it, and then they use it for injection molding parts. Then they get some parts out of it. Then they can sell the parts. Then they get some money. So it is a continuous process of being in an entrepreneurship mode. Even housewives can do this. It is not that it has to be done only by industrial people. If you are wanting to do it at a household level, it is more than sufficient for retired people, more than sufficient for all the household people to convert waste to wealth. They get money instead of wasting.
Mr. Shishi, good afternoon. Balaji here.
Yes, sir.
Sir, these bottles which are shredded and that becomes, you said it will become in the form of pellets, right?
Yes, sir.
And who are the people who may be generally buying this? How do we find market for these pellets, sir?
Sir, there are, there are a lot of people who are there for collecting plastics and selling it. In fact, I know that in Bangalore also there is one person in Rajajinagar who is actually keeping all these plastics. And they convert and they buy all this plastic powder. They are making also. If you have seen some of the people nowadays on the roadside at the signal lights, they're selling some plastic parts.
Correct.
People know when you drive your car somewhere on the roadside near the signals, they sell parts.
Yeah.
Actually, they are making out of all these things.
See, basically, I've seen in Pinia, there is a company which actually buys all these bottles and then they make it into huge, they press it and it is made in terms of blocks.
Correct.
And I understand these blocks are also used for roads, no, along with the mixed with the tar, which gives a better life to the roads.
Exactly. That is also used. It is used for that purpose also. This was done by, I think, there was a company in Kenya who is doing
Yes.
it for putting it into roads.
Yes,
And
yes.
what this is another way of using it for our own benefit. See, when whatever plastics we are using in our house today, we are putting in garbage. Nobody is paying us any money.
Correct.
And the corporation is taking all this waste, they are segregating. And this Pina company is buying from corporation,
Okay.
and they are using it for making selling it again to corporation after converting it into some like a gelatin metal which can be used along with the roads. But this is what I am talking about is a concept. Waste to wealth is community wise, house wise. A group of people can nearby can use it, and they can make benefits for their own for the community at large. That's the whole idea.
But will there be any
Necessary.
liquid which gets produced out of this, sir? No.
No.
Only the piece gets converted into small pellets.
Whatever, yeah, exactly. It gets like a powder.
The product image sir is already given the tiles.
Yeah, like tiles you can have. Na?
Yeah.
You can put it in
Voice,
front of your
hello.
house. For example, if you make this tile, you can put it on the, I mean, just in like a plastic tile, it can be put in front of the house.
What are those interlocking blocks you have shown, sir?
No, that is the tile only. You just use the
Okay.
sheet press.
Oh,
In
okay.
the sheet press, you have made a small, we just cut a MS hexagon shaped thing, put the powder inside and heat press. It will become like a tile.
Okay.
Yeah, the bigger tile can be used as a road.
It can, whatever. It can be kept in front of the house. It looks nice also because you're mixing different colors. Na? If you see,
In fact, an entire layout can be made by entire layout. If it is a housing, a private colony, a community, living community, entire road can be made of this.
see, yeah, it depends on the plastics generating. And see, what is happening out here, sir, is if you take about 1 kg plastic, its volume after you shred will become like this much big. So when you again compress it and put it and make it like a thing, it looks very nice because you have different colors getting into it. Like you have red color, blue color, and all. No? So that gives the mix of all these things.
Sir, but mixing of plastics will not create any trouble, sir?
Nothing will happen. It is just simple plastic which will mix and you will get a composite material. And we are not going to use it for anything else. We're going to put it on the floor.
Okay.
It really doesn't matter to us, or it is just used as a showpiece. You're going to keep a pot on that, or you can hang it, or some general purpose. And
What is, excuse me, sir.
that we are using also is what we get in what we buy from the market along with food grade. For example, you buy oil, it comes in a plastic bottle. That anyway, that it's used for food grade as it is.
Yeah.
Bench.
Sir?
Hello.
Yes, sir.
For this, making these stools and benches, what do we need? We need first dyes, no? We need dyes, or without dyes also we can make it.
Yeah, without dye. For example, this is in a bench press. Like I told, no, this is a press.
Press.
This rectangle shape, if you want, it is on a press machine. Press machine is basically you have top and bottom heater, and you make one small like a hexagon shape. You'll have one MS hexagon shape welded and kept. That may cost you only about 500 rupees, for example. And then you heat it and you put all the powder inside this and heat it on top and bottom. It will become like a press. It will become that shape that you want, like a tile or a stool or everything.
This all parts, if I want to see, if I want to purchase, I want to see, I have to come to Bangalore, or I'm staying in Delhi actually.
Sir, you can make it and you can see in the website also. Hello?
Hello.
Sir, I'm not able to hear, sir.
Yeah, can you share the website link?
Yeah, I'll send it.
Website link.
Plastics.co.in or preciousplastics.com.
Sahana Sahavir Karavavahai तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः हरिः
Hearing this mantra, Shanti mantra, who's
Sir,
saying? Hello.
sir, tell me, sir.
Yeah. Delhi. Have you sold your industrial part, this cheddar machines, all these things? Sold in nearby Delhi? I want to see.
Sir, our 3D printing machines you can see near Delhi, sir. You can see all our machines over here. If you go to IIT Delhi, you can see our 3D printing machine. You can go to many companies in Kanpur, HTBU college. They are all purchased our machine.
Sir,
Or
are
I
these
have to come
machines
to Bangalore.
manufactured in the same campus of AMS, sir?
Pardon me?
Are these machines manufactured in the same campus of AMS in Peenya, sir?
Yeah. Yes, sir. Same.
Because I'm a regular vendor to AMS.
Oh.
Yeah. And I was working for Kenametal, sir. SPM
Oh,
division.
great.
So, sir, machine line you are the in charge, sir?
How's
Okay. Can you kindly share your number, sir, so that we can contact you, sir?
Yeah, share also.
Shall I put it in the chat? Or
Yeah, please. That will be great,
Yeah,
sir.
put it in chat. Yeah. Your number and link, na? You just text in the chat box.
I'm doing it right now.
How much cost for all these things level of starting the business? How much cost comes roughly?
Not much, no, sir. 1,50,000
For
for
starting business?
the shredding machine to begin with, sir. Nothing more.
Hello, can you hear me?
Sir, tell me, sir.
Approximately, we need 2 lakhs around, right?
Yeah. 1.5 lakhs to 2 lakhs will be more than sufficient to begin with.
We need, before starting business, we need some, knowledge or trainings type something.
Sir, all that we will give free, no problem, sir. You can actually take the machine and do it. That is all not a problem, sir.
Here to teach all these things.
Yeah. You will get all the information, sir. No problem. We will give everything.
ठीक है अभी लॉकडाउन इज स्टिल ना अभी यहाँ से दिल्ली से बेंगलोर की ट्रेन भी अभी नीचे कम चल रही होंगी अगर बेंगलोर आना पड़ रहा है
Yes, sir.
तो वहाँ देख सकते हैं बेंगलोर में
Sir, I'm not able to hear, sir.
हेलो कैन यू हियर मी हेलो
Sir, tell me, sir.
Where is a plant in Bangalore?
Yeah. We have a factory in Bangalore. We are making these machines and sending it to thing. In fact, to Delhi, we are sending one machine. Just recently, we have sent one machine. They are using it in Delhi. FSM in IIT Delhi.
अच्छा IIT नहीं
IIT. You can go there and talk to one Mr. Naman Kapoor, Dr. Naman Kapoor.
Dr. Naman Kapoor.
Yes.
Okay.
You can see the machine there.
So I can visit there. You tell
can.
your name.
And you can see the machine, 3D printing machine. No problem.
The 3D printing machine.
Yes. And you can also go to IIT Textile Department. There also there is one there are 3 machines in IIT Delhi. And also in this YMCA, they are buying one machine now. If you are near Kanpur, or
YMCA.
yeah, there also they want to buy a machine.
Sometimes your voice is breaking. Sometimes voice is not clear. Hello.
Yes, sir.
Sometimes voice is breaking actually, na. Network
Yeah,
problem, I think.
I could not hear properly what you are telling.
Yes, network problem, I think. My location.
Okay.
Network is very weak, na.
Yeah.
Everywhere network
So
problem.
friends, thank you very much. What we will be doing is now, we will be writing to all of you, since the thing is downloaded with a questionnaire. We request you to fill the questionnaire, maybe in a day or two. Wednesday or Thursday, you will get the email from us with a questionnaire. We request you to fill the questionnaire and send it to us. And what we will be doing is that based on the questionnaire, we will be now looking forward for this as a uh, kind of a proposal, wherein how we can put this machine to use, and how the consumption of this plastic can be increased. Now you see the machine itself is creating the product based on the machine. Now we would be even having our next webinar will be with the how the finance can be made, arranged, and things like that in the next 2 weeks time. So I request people to really be ready in the next 2 weeks, and also please come up, please have a plan in mind. How, having heard the webinar, please scribble a few points in your notebook as to how you would like to, which are the areas you can look at implementing this particular project. So thereby we will even be looking at having the finance team with us, a neat project, and how we can implement this. So that is what we will be doing in the next few days. I hope that you have found this webinar quite meaningful. If you have found it meaningful, and if any questions are there, you may please type on the chat box, yes, it was meaningful. If any questions are there, you can also type the same, so that in our emails to you, we could in detail. Yeah? Yes? Since the networks are weak, we may not be able to hear you properly. So that's the reason. I hope most of you appreciated this webinar. I really thank you very much for your. I have a question regarding the compression heat melting. Compression heat melting. Okay. Mr. Mistry, I have your email. I mean, please WhatsApp to me the question, and I can forward that to Mr. Shashidhar, who will answer you. I think the audios are getting breaking since it's already 1.5 hours since we are on. So please send me that question, Mr. Mistry, and I shall, yeah. Mr. Shashidhar, Mr. Mistry is a product development consultant. So he will be asking a question. You may please answer it.
Okay, sir. I'll.
Yeah. So Mr. Mistry, send it
Can the
on.
numbers be shared, please?
Yeah.
Rishi and Mr. Rajiv, can you please share the number, sir? Contact number?
I put it on the thing 98450
You have shared in chat box?
Yeah, chat box I put my number 98450
I'll take it from there.
98450
71820.
71820. Thank you.
Can you, Mr. Shashi, can you share your product catalogs?
Yes,
Whatever you're making, can you share the product catalogs? Can you email me?
Okay.
I'll forward my email to you.
Okay.
Just share your products. Can we market your products here in Delhi?
I have 100%. I'm actually putting my website also. I put in the thing, mobile number.
Hmm. I'll call you. I will call you.
Okay,
Okay.
sir.
Hmm. When you are free, when you
Anytime.
will free, yeah, your time just your time.
Yeah, yeah. No issues. And
Okay.
then give me a
Oh.
call.
Hmm. Oh. Okay. Oh. Thank you, sir. Thank you.
Thanks.
Mr. Dhanesh is from the Skill Development Council, sir, in Gurgaon.
Oh, okay, okay.
Not actually, not Gurgaon. The skill development office is located in Delhi actually.
Delhi, yeah.
Yeah, but this main office is near Gurgaon. But actually, I'm an assessor, no? I'm an assessor actually. I'm examiner. But nowadays, the all system is locked down. So from March, no assessment from March to 2020. So still we are waiting to open the project, PMKY project. Still it's locked down actually. So nobody knows, nobody no update regarding when it will open assessment actually. All centers are closed. This electronic sector is closed. All offices are closed actually due to COVID. So no update actually in this field. Regarding that. So
So,
next training you
with-
will update us
yeah.
about
So
next
with
training.
this, we would really call an end to this workshop. My number is also given on the in the chat box. I really request all of you to be in touch with us, and whenever you get our webinar invitation, I request you to I really request you to pass it on to more people and and really support us, and let's all together really bring in such products so that our incomes also go up, right? So thank you very much. Thank you. Nice meeting all of you. Please be in touch. Thank you all very much for the time. So thank you very much for the time.
Thank you, sir.
Thank
Thank
you,
you.
sir. Thank you. Thank you. Thank you very much, sir.
Thank you. See you the next few days.
Sure, sure.
Sure, sir. Sure.
So thank you, sir.
Thank you. Thank you, Mr. Rajit. Long time. Smita, madam, you can just be there. I will introduce you to Mr. Shashidhar.
Yes, sir. Yes, sir.
Hello. Santosh,
Hello, Mr. Shi.
Yeah. Sir, tell you.
Hey, where's your number? You text your number in chat box.
Chat box, I put my number, sir. 9845071820. Abhi laga danga again.
Can you share it again? Not showing.
Yeah, I put my number just now, sir. You can see.
Okay, 98450.
9845071820.
7820. I'll share my email to you.
Yeah, please tell me your what's your number, sir?
My number? Yeah, I'm sharing. Yeah.
I can note it down and save it.
Two numbers.
Or what's SMS me, sir? I will call you.
Yeah. So I'm using two numbers.
Okay.
This is one. Another one.
Sir, I just want to introduce you to Smita.
Okay, sir. Good afternoon, madam.
Good afternoon, sir. Sorry, sir. Um, yes, I first let me tell you, I really enjoyed it. And I have been following all the webinars which Rajiv sir and you have been hosting. And yes, I'm an electronics engineer, and one of my client is also a 3D, was into 3D printing. So it's a very interesting subject.
Yes, madam. Are you from Bangalore or from which state are you?
Yes. Nan Bangalore nole, sir.
Okay. So it's a pleasure to meet you, madam. Anytime
Yes, sir.
factory machine ಎಲ್ಲ ನೋಡಿರಂತೆ you can see
ಇಲ್ಲ ಹೌದು, ಇದು ಒಂದು ಲಾಂಗ್ ಟರ್ಮ್ ಪ್ಲಾನ್ ಆಗ್ಬಿಟ್ಟಿದೆ. ರಾಜೀವ್ ಸರ್ ಹೇಳ್ತಾ ಇರ್ತೀನಿ ನಾನು, ಒಂದ್ಸತಿ ಬರ್ಬೇಕು ನಮ್ಮ ಟೀಮ್, ವಿ ವಾಂಟೆಡ್ ಟು ಹ್ಯಾವ್ ಅ ಲುಕ್ ಅಟ್ ಯುವರ್ ಪ್ರೊಮೈಸಸ್ ಅಂಡ್ ಆಲ್ ದ ಇದು ಅಂತ. ಅದು ಐ ವಿಲ್ ಟ್ರೈ ಟು ಡೂ ಇಟ್ ಸರ್ ದಿಸ್ ವೀಕ್, ಮೇ ಬಿ ದ ಕಮಿಂಗ್ ವೀಕ್. ಯೆಸ್, I'll try to visit you. It will be good, so that like Rajiv sir was also mentioning about the program, the theoretical program, what could run along with your practical sessions.
Yes.
So in that case, we need to see the whole thing.
Correct. And electronics nalli, what exactly are you doing?
Sir, I am into certifications. That is, ISO certification is my core area.
Okay.
So I also audit for I'm an empaneled auditor for a certifying agency for electrical, electronic, and computers code. These are the industries I can audit. Yes.
And you are working with TUV? You are consulting?
No, sir. No, I'm an empaneled. In the sense, I'm not on payroll. So
got it.
yeah, whenever they need a requirement, I am. So I am tied up with TUV, sued as a this one, sir, and also with ICS, International Certification Service.
Got it. TUV suit is in Pune, next to design office. In,
yes.
Kushal Garden. Our design office is in Kushal Garden. I have about 100 people design office there. KW work. That is in the Kushal Garden.
Oh, how that? Okay.
And, factory is in the SRS road.
On SRS. Okay.
And recently, madam, we got one good this thing. During the COVID time, I made a paper for Technology Development Board, Department of Science and Technology, thermography based image processing and gate system. It is a system that you have developed. It's an electronic box wherein you have gates there that is opens and closes, but it checks the temperature of the person, it checks the face recognition, identification, contact tracing, and it is IoT driven, so it saves it on a server remotely, and then everything, it checks the Arogya Setu app, and if it is okay, it will open the gate, otherwise it will not open the gate. So this system was approved by TDB, and it is there on the TDB website, Technology Development Board website also they have put. And that also we are product we have developed right now. We have not gone through any certification at the moment, but I don't know, maybe we may have to go through some details later. They told there is a NABL and there's some certifying agency who does
yes, sir. That is the National Accreditation Board for Laboratories.
Got it. Okay.
I think, it will have to undergo that. That is 17025 or something, because it will be connected with the humans, right?
Yeah, it is
So
for bolometry. It's actually a thermographic sensor. We have to, the bolometer measures the temperature of the person, and the image, it takes the image of the person's face, and it also has facial recognition. It recognizes the human face and the two eyes, and the temperature has to be taken exactly in the canthus area. That is exactly between the eyes. There is one point, so we have to measure at that point only. Only then the temperature will be reading is correct. And also takes the Arogya Setu app reading and measures his contact tracing. That means where he has gone and all that. And
very
then
nice.
will allow the gate will open if everything is okay. This is the system. The gate is normally one motor active. We have made one system to open the gate, but the